Mode expansion monitors allow you to analyze the fraction of power transmitted into any modes of interest traveling in a waveguide or fiber. It works by expanding the field profile measured across the cross-section of a waveguide or fiber onto the supported modes of the waveguide or fiber. In this example, the fundamental mode is injected into the narrow waveguide. An expansion monitor is used to determine how much power couples into the fundamental mode of the wider waveguide. In this case, the coupling efficiency is about 75%. The mode expansion monitor includes an integrated mode solver to find the supported modes of a waveguide or fiber given the cross-section of the device by using the finite difference eigenmode solving algorithm. This is the same mode solver as used for mode sources that we saw in the sources section of this course. You can edit the monitor and select the modes of interest. The mode expansion monitor itself does not measure any simulation data, but instead it takes the field data measured by the specified frequency domain field monitors and expands the monitor data onto the selected modes of interest. Frequency domain field and power monitors are recommended for this since there's less interpolation error compared to frequency domain field profile monitors. For broadband simulations, it's recommended to increase the number of frequency points over the wavelength range to calculate the supported mode profiles of the waveguide or fiber, since the supported mode profile can change as a function of wavelength. This can be set under the Mode Expansion tab of the Mode Expansion Monitor edit window, and since the modal fields usually change slowly over wavelength, using a small number of frequency points such as 3 or 5 points is usually sufficient in order to get accurate results. Overlap calculations are performed between each selected mode and the fields measured by the frequency domain monitor in order to determine the coefficient giving the fraction of power which is traveling in that mode. For broadband simulations, it's fine if the number of frequency points over which the modes are calculated doesn't match the number of frequency points measured by the frequency domain field monitor, since the mode profiles will be interpolated to the frequency points measured by the frequency domain field monitor. After selecting the modes to expand, the effective indices of the modes and the mode profiles can be viewed as results from the mode expansion monitor. After running the simulation, the mode expansion monitor returns expansion results listed here. The transmission results, T-total, T-net, T-forward, and T-backward, give the total transmission through the monitor, the net transmission into the selected modes, the forward propagating transmission in the selected modes, and the backwards transmission in the selected modes, respectively. Forward and backward here refer to the positive and negative axis directions. The A and B results are the complex transmission coefficients of the forward and backward propagating waves of the selected modes, and these can be used to calculate the S parameters. More details about the results can be found on the Using Mode Expansion Monitors page, linked below. Mode expansion monitors can be useful for simulating devices like polarization converters, where you want to extract the conversion efficiency from input mode to output mode, or extract S parameters of a device. However, if extracting S parameters, the port object can also be used. And we'll go over ports in more detail after we first demonstrate the setup and use of a mode expansion monitor in the next unit.